Hello, welcome back. The title of this lesson is called The Mean of a Data Set, Part 1. Has a fancy sounding title, but I promise by the end of it, you will not only understand what the mean is, but also how to calculate the mean of a data set, also what the mean is used for, and basically in general why it's a useful concept, right? And it's not a hard concept at all. So we have data set. We want to try to represent what the data set looks like, but we also want to try to boil that data down to like a single number that represents the numbers that we have in our data set. That one of these ways of doing that is called the mean. Now there are other ways of representing the center of a data set, which is one way it's called the mean. We're also going to talk about those later. We have something called the median and we have something called the mode. They're just different flavors of doing a similar idea. We want to boil that data set down to a single number to represent kind of its central value. So let's take a look at our first data set. We have 2, we have 6, we have 4, we have 8. What does this data represent? I don't know, you can make up whatever you want. It could be the number of brothers and sisters that somebody has, in your classroom. So this person has 2 brothers and sisters, this person has 6, this person has 4, this person has 8. It could be the number of moles they have on their back, whatever. It doesn't matter. The numbers are what the numbers are. But we want to calculate the mean so that we can try to boil this data down into kind of a single number, which represents kind of the middle number, the middle of the road value that represents all of this data. That's what we're calculating when we calculate the mean. Now, before we actually find the mean, we're going to plot these numbers on a line plot so that we can get a visual representation of what this data looks like. So what we have here is we have somebody that has 2 brothers and sisters. So we have one person actually has 2 brothers and sisters. So 1x means one person has 2 brothers and sisters, right? Another person has 6 brothers and sisters, so we'll put a single x right there. Another person has 4 brothers and sisters, we'll put a single x right there. And another person has 8 brothers and sisters, we have a single x right there. So notice that this data, it's not super clustered around one number. It is kind of spread out, but also the values are not like so far apart from each other, right? We have 2 brothers and sisters and 6 and then 4 and then 8. We don't have any real outliers. Remember, we talked about the concept of an outlier in the last lesson. An outlier is a data point that just doesn't make sense at all. It's way out there. Like, for instance, if you have 2, 6, 4, 8 brothers and sisters, what if you had somebody with like 30 brothers and sisters? Okay, it's probably an error in the data. It's not probably real, but there are people on planet Earth that have had 30 children. It is possible to have that happen, especially if you have triplets or something like that, and you do that several times. You can have 20 or 30 people. So that would be an outlier. But this data doesn't really have an outlier. All of the numbers are pretty close to each other. We don't have any outliers. The reason I'm mentioning that is because we use the mean, which we also refer to as the average. Average and mean, they mean the same thing, right? So the average value or the mean value, it's most useful when you don't have any outliers. I'll explain why in just a minute, but just keep that in mind. We use the average so much when we don't have any crazy data that's just way far away from most of our data. In this case, most of the data is clustered between 2 and 8. And yes, it looks like it's a little spread out in this chart here, but really all the numbers are pretty close together. Now, how do we boil it down, this data, for one average value or mean value? What we do is we add up all of the numbers in our data set. Here we have 2 plus 6 plus 4 plus 8. And then after we add it up, we divide that number by the total number of numbers in the data set. So there's 4 numbers in here. So we add them up, divide by 4. That's how we find the mean, or also called the average value. So let's go down here and calculate the actual average value here, right? So what we're going to do is we're going to take the 2, we're going to add it to the 6. Let me get to my next page of notes here. 2, add it to the 6, and then we're going to add it to the 4, and we're going to add it to the 8. Now you can do column addition, you can add on your fingers, you can use a calculator, whatever you want to do, but when you add all of these up, you're going to get an answer of 20. So when we add up all the numbers in the data set, we get an answer of 20. Now the next step is we take I'll put average, mean here. Average and mean mean the same thing. When you add them all up, you take that number, in this case 20, and we're going to divide that number by however many data points we have. We have 1, 2, 3, 4 data points, 4 numbers. So we divide it by 4. Or another way of saying that is we take 20, the top number, and we divide it by 4. Now, 4 times what is 20 is 5, right? So the answer that you get is 5. So the average value is 5. The mean is 5. So I'll say this is what we call the mean, or what we call the average value. This average value should represent the center of the data. It doesn't have to be right in the middle of all the points, but it should be some representative number where we can boil all of these data that we have down to a single number which tells us kind of what the central value of the data is, right? And if we were to look on this line plot and put the mean, notice the mean is 5. 5 is right here. We don't have any data point exactly at the number 5, but this number 5 is the mean. So I'm just going to put that on there. Now I want you to stare at this drawing and just try to take it in, right? What it's basically saying, I guess I can put like a dot or something right here, right at the mean, right? This is telling you that we have data, one data point at 2, one data point at 4, one data point at 6, and then one data point up here at 8, right? And when we try to find a central value of this data, a central number that boils it all down to an average, or also called the mean, of the data. In this case, it's number of siblings or brothers and sisters. The average value is 5. That means instead of talking about the individual numbers of brothers and sisters, I just talk about the group. I say, on average, this group of people has, on average, 5 brothers and sisters. Now notice that nobody actually has 5 brothers and sisters, but still, it's a middle-of-the-road number that represents all of the data. That's what I mean when I say I have data, and I want to find the middle of the data. I average the numbers, and I find and calculate a single number which falls mathematically in the middle of the data, and that tells me as a group or as a whole what is the average value of all of that data. So on average, everybody has, in this data group, 5 brothers and sisters. Some have more brothers and sisters, and some have less brothers and sisters, but as a whole, as a single number to tell me, like an average grade in the classroom, it's telling me the average of this data, just like the average grade in a classroom. We have some people get 90s and 100s, some people get 70s and 60s, but as a class average, there's a single number that we average in the middle we call the average value, or the mean, right? Now, the way you find the mean, again, we just said we add up all the numbers in the data set, and then we take that number and we divide by the number of data points we have. So add them up, divide, in this case, by 4, we get an average of 5 there, and we put it on our chart to show you that it's basically right there in the middle of the data. Now, the next thing I will say is that I told you that the mean, or the average value, we use it when we don't have any outlier points, right? Why? Why do we care about that? Because if I was collecting this data, and let's say this person told me 2 brothers and sisters, 6 brothers and sisters, 4 brothers and sisters, 8 brothers and sisters, and then somebody told me 40 brothers and sisters. Or let's say something crazy, 100 brothers and sisters. Okay, I know that that 100 is in my data set, but it's probably an error. Somebody probably typed it into the computer wrong, or somebody just misunderstood the person when they told them on the phone how many brothers and sisters. They thought they said 100. But if I calculate the mean, including a crazy outlier like 100, then I'm going to add up all the numbers, and I would have to add 100 in there, and I would divide, and I would get, my mean would be way skewed farther to the right, closer to 100, because I would be including that 100 in my calculation. So we really don't use the mean unless our data is nice and well behaved, no outliers. We have something called the median we're going to learn about in the next lesson. That one we use a little more often when we have outliers in the data. And I'll get to that later when we get there. I just want you to know we use the average value, or the mean, when we don't have any outliers. Here we don't have any outliers, so there we're using the mean. All right, let's take a look at problem number 2. Here's some data here. We have 17, 11, 10, and 18. I don't know, you can make up whatever you want this data to represent. Let's say you ask 5 people or 4 people how many chicken nuggets they eat when they eat chicken nuggets, or how many French fries they eat, right? And one person tells you they eat 11 French fries, and another person tells you they eat 17 French fries, and somebody else tells you they eat 10, and somebody else tells you they eat 18 French fries. Right? So let's first see what this data actually looks like. Well, one person tells me they eat 11 French fries. One person tells me they eat 17 French fries. One person tells me they eat 10 French fries. And one person tells me they eat 18 French fries. So you can see that the data, I have kind of a cluster over here, and I have kind of a cluster over here. Doesn't seem to be much in the middle, but still, I don't really have any outliers, because you know, 11 to 18 French fries, none of those numbers are unreasonable for the number of French fries you might eat. It doesn't, like if I had somebody told me they ate 300 French fries, I would think maybe that's not right. Maybe that's an outlier. But if they tell me 20 French fries, it's probably okay. It's probably reasonable. So I don't really have any outliers. So let's calculate the mean to figure out what the central value of this data is. All I do is I add up my numbers. I have 11, I have plus 17, plus 10, plus 18. Again, you can add all these up in a calculator or by hand, and you'll get 56. All right. The next thing I need to do is I'm going to take that 56 and I'm going to divide by 1, 2, 3, 4, right? 56 divided by 4. Now, I'm not going to do this for every problem, but I'll do the long division here, but after that, I'm not going to do it very much because most of the time you'll probably use a calculator. So this goes one time, you get a 4 here, drop a 6 down, and then 4 times 4 is 16, remainder of 0. So when you get an answer of 56 divided by 4, you get an average value of what we have on top here, 14. So the average value is 14, right? So where does that fall? If I look in my chart, right here is 14. This is the average, also called the mean, right? And I'm going to put a little dot here. And notice again that the number 14 itself does not appear in my data set. So I'm trying to show you visually that the average value often is not in your data set. It doesn't have to be one of the numbers in the data set. It's a calculation. You add them all up. So you're taking into account the values of all the numbers in your data set, but you're dividing by 4. So you're adding them all up, taking them all into account, but then you divide them by 4, which means you divide it evenly. And so you're basically smoothing everything out and you're finding the central value. In this case, the central value is exactly in the middle. You have 2 points over here and you have 2 points over here. And it does happen to be exactly right in the middle with an average value. All right, same as we had right here. We had an average value where half of the data was on the left and half of the data was on the right. It doesn't have to always be that way, but it is that way in these first two problems. Now, let's go on to problem number 3, and you will see that the mean does not always fall right in the center of the data. So here we have some data, 733 or 73834. I don't know, this could be the number of sunburns somebody gets in their lifetime. Person number 1 tells me they get 7 sunburns in their whole life. This person had 3 sunburns, 8 sunburns, 3 sunburns, 4 sunburns. So we're looking in this case, I'm just making this up, the number of sunburns that we have. So take a look. We have this person. We have one person tell me they have a total of 7 sunburns. One person has 3 sunburns. Another person has 8 sunburns. And this person, here's another person, a totally different person that got 3 sunburns. So I'm going to put that X right on top of the first X right here, there. And then, of course, the last person, again, only had 1 sunburn. So this chart immediately looks different than the other ones. Notice the other ones just had a single value at these data points. Here I actually have 2 people giving me back the same number. And in real life, you're going to have people telling you duplicate answers all the time. So let's try to calculate the central value and find the mean or the average number of sunburns that these people are reporting on average. So the way we'll do it is we'll just add up the numbers. We'll take the 7, we'll add the 3, we'll add the 8, we'll add the 3, and we'll add the 4. So 7 plus 3 plus 8 plus 3 plus 4. When you add all of these numbers together, you will get an answer of 25, right? And then the average means that I have to take that 25, the answer I got from this, and I'm going to divide by 1, 2, 3, 4, 5. Divide by 5 because I have 5 numbers and I want to represent it equally among the 5 data points I have, so I divide by 5. And 25 divided by 5 is what? Is 5. So the average is 5. So on average, people in this data group or in this group of people received 5 sunburns in their life. So let's go off to the chart and let's figure out, here's 5, so I'll put like a big thing here and I will say the mean is right here at 5. Now it's really important for you to understand, obviously the average number of sunburns these people have received is 5. 5 is nowhere in my data set, so again, the mean or the average value does not have to appear in your data set. It's just a number we calculate that is the quote-unquote center of the data. But look at it. It doesn't really look like it's in the center of the data, right? In the previous 2 examples, the mean was right in the center of the data. 2 points to the left, 2 points to the right, right in the middle. This one right here, the average or the mean was center. 2 points to the left, 2 points to the right, right in the center. But this one is different because it is really not in the center. The mean is a little bit closer to these 3 points, and then these are a little farther away. Why do you think that's the case? The reason it is skewed a little bit over this way is because I have 3 data points here, and 2 of them are on top of the number 3. So the average or the mean is trying to find the center of the data, but it doesn't really literally mean right in the middle of the graph. It means it's trying to take into account all of the values. And so it looks like the center of the graph might be here, but it's skewed left because I actually have 2 data points that are weighted down here at the number 3, so that's pulling the mean a little bit to the left. I do have some people with higher values, but only 2 points. And I have some people with lower values, and I have 3 points, and 2 of them are very, very far to the left, and that pulls the average down. Think about grades in a classroom. If you have 2 people that made 95, but then like 3 people that made a 40, then those good grades are awesome, but the 3 people that made bad grades are going to pull the average down for the class. And so these data points, especially the 2 people that had 3 sunburns, it's pulling the average down. So we would say on average, this set of people, or this amount of, these people in particular, had an average of 5 sunburns in their life. It's just a representative value. There are no outliers here. These numbers are reasonable. There's not, like, nobody reported like 72 sunburns. That would be an outlier. So it's okay to use the mean. We don't have any outliers. We calculated, we found the average value, also called the mean. Now, let me take this down. I have one more, and then we'll wrap up this lesson. All right, here's our last problem. The data is 7, 4, 15, 5, and 4. Let's just say this is the number of dollars that different people make mowing lawns in the summer, let's say. Person number 1 made $7 mowing lawns. This person made $4. This person made $15, $5, and $4. This is the number of dollars people make mowing lawns, right? So let's first see what the data looks like. Is it all clustered around a number, or is it all spread out? Well, one person reported earning $7. Another person reported earning $4. Another person reported earning $15. Another person reported earning $5. And another person reported earning $4. So here's a duplicate with this 4, and so really 2 people reported earning the $4. Now, before we calculate the mean, let's try to predict. Where do you think the mean is going to be? The mean is the average value, trying to predict the center of the data. Now, not literally the center. I mean, the graph is this big. The center is right here. I'm talking about the weighted center. In other words, the center or the mean is going to be a representative value for all of the points in the data set. So if we have a cluster of data, the mean is going to move that direction a little bit. It's going to be somewhere between the extreme of the lower and the upper numbers, but it's certainly not going to be way over here. The mean is not going to be 14 because I only have one value up here. Most of the values are way down here. So I would predict that the mean cannot be over here, and it's certainly not going to be way over here because I have data points that are higher. It's not going to be here because most of the data is far below. I think the mean is going to be somewhere around here because this would be the absolute center of the chart, but it needs to shift left because some of the data, or most of it, is pulling it this direction. That would give you the average value of this data because most of it is clustered down over here. Now, you could say that this is an outlier, that 15 is an outlier. It's very different than the other ones. It's true, you could. But in this case, what did I say? The number of dollars somebody made mowing lawns, it's not unreasonable. Somebody could make $15 mowing lawns, so I'm not going to consider it an outlier. If somebody told me they made $7,000 mowing lawns, probably not going to believe that number. It's probably an outlier. But here, I think it's perfectly reasonable. Somebody could make anywhere in this range of money here mowing grass. So let's find the average value. We'll take that 7, add it to a 4, add it to a 15, add it to a 5, and add it to a 4. And when I run that through a calculator or just do column addition with it, I will get a number of 35, right? And then, in order to find the average value, I'm going to have to take that 35, right? And I'm going to have to divide it by 1, 2, 3, 4, 5 data points. I have 5 data points. So I take the total amount I added, the sum of everything, and I divide it by the number of data points, which is 5. 35 divided by 5 is 7, because 7 times 5 is 35. So the average, also called the mean, is equal to 7, right? 7. So let's see where this thing falls. I guess I'll circle this guy. Let's see where it falls. 7 is right here. And so I'm going to put a dot right here. I'm going to put an arrow, and I'm going to write down that this is the mean, right? Now, this is actually the first time that the mean happens to line up on the same number as one of my data points. If you look before, here the mean was here, but there was no data point at 5. And if you look right here, the mean was at 14, but there was no data point at 14. And then, I guess that's all I have. I had another one that I took down to solve this one, but in that case, it wasn't. It didn't line up either. But here, the actual average value, or the mean, is a 7, and 7 happens to be one of my data points. So I'm showing you visually that it is often the case that your average value is not one of the numbers in the data set, but it can be. There's nothing wrong with that. So here, the average, or the average number of dollars that the people in this set earned mowing that grass is $7. Some people earned higher. Actually, only one person earned higher. Some people earned lower. And some people earned exactly $7. So as a whole aggregate, I can look at this group of 5 people and say, on average, they earned $7 mowing lawn. So you can see that in this case, we have used the idea of the mean to find kind of the central value of the data. Right? We said studying statistics, we're going to be concerned with mainly 2 things. What is the center value of the data? And also later, we're going to talk about the spread of the data. So here you can see, here's the central value of the data. This is the spread of the data. Some data is lower, some data is higher. We can see how spread the data is. Here is the center of the data. Here is the spread of the data. Here we're finding the mean, which is just calculating the center of the data set. Right? Later, we'll learn how to calculate how spread out that data is, so we can then learn what our data set really looks like, if it's spread out or if it's clustered, right? Again, we use the mean as a calculation. We don't have any outliers. And even though this looks like an outlier, we explained that it's not really an outlier. If you do have outliers, like if in this case, if it was earning money mowing grass, if I had somebody tell me they earned $7,000 mowing grass, if I included that in my calculation, I would have to add 7,000. And instead of dividing by 5, I would divide by 6, because I would have a 6 data point. Then what would happen is, because that number is so big, it would pull my average value much, much closer to the right, because 7,000 is so large. So we don't want to use the mean when I have a ton of outliers, because it kind of, it pulls my actual representative center value very, very far one way or another. So we don't really use the mean when we have large outliers. We use something I will show you a little bit called the median for that. So I'm trying to explain that we have different ways of writing down the center value of a data set, and we use them in different situations. So here we learn how to calculate the mean. I'd like you to calculate all of these yourself, and then follow me on to the next lesson. We'll get a little more practice with finding the average value, also called the mean of a data set.